here on online platform on the occasion of National Science Day or Rashtriya Vigyan Divas, which is celebrated on February 28th every year to commemorate the discovery of Raman effect. It is a phenomenon in spectroscopy by our Indian physicist Chandrasekhar Venkata Raman, C.V. Raman. He discovered this Raman effect while working in the laboratory of Indian Association for the Cultivation of Science, Kolkata. And for this discovery, he was awarded the prestigious Nobel Prize in Physics. Since 1987, India has celebrated this day as National Science Day to pay tribute to this great scientist. The objective of celebrating this National Science Day is to propagate the importance of science and its application among the common people. Theme for this year of National Science Day is Integrated Approach in Science and Technology for Sustainable Future. And the theme has been chosen for the purpose of raising public appreciation of scientific issues involved. Now I would request our principal ma'am, Dr. Meenakshi Chakraborty, to present a welcome address for on this day. Ma'am, please. ম্যাডাম আপনি একটু আনমিউট শোনা যাচ্ছে? শোনা যাচ্ছে এখন শোনা যাচ্ছে ম্যাডাম। আচ্ছা, because the other day I couldn't be heard. Yes, right. Before I begin, I just wanted to ask the organizers, Abir, Meeta, and everyone who's present here, if we are doing a little bit of documentation of this event, since we do it every year, right? The Science Day, and Abir plays a very major role in observing Science Day in our own little way, in our own little college, Kalipada Ghosh Torai Mohavidyalaya. Thank you, Abir, to begin with. And a very good evening to all my dear colleagues, my dear students, and all of us who are present here today, because we know, and we know from the bottom of our heart, that without science, we really don't progress. Science and technology. Just now, Meeta ma'am mentioned that this year, rightly, the theme is Integrated Approach in Science and Technology for a Sustainable Future. So we can well imagine that the sustainable future, these are the two key words which is really haunting us. We all have been hearing that our life in the planet is changing, and it is changing very fast. Very, very fast. And are we in a position to keep this earth as we found it, even as we found it, so that we can leave behind something for our future generation, which they can use for their development? Or are we being extremely selfish? This is something which is really haunting us. Because if I talk absolutely about routine matters, something that we all see and hear, that is, we hear these days that the seasons have changed. We hear these days that there will be no rains, there will be no rainy season unless and until there is a depression somewhere. So what is happening? We all have heard, even I am not at all, how would you say, very erudite in many of the new scientific discoveries. But I have heard and felt that there's a big chunk of iceberg which is roaming about and creating a lot of disaster in this world. Very soon, many things are going to disappear. We will not be able to see maybe our favorite penguins anymore. So, science and technology, core science and technology, if these two don't move hand in hand, and if they don't keep the thought of sustainable development, it's just not development, it is sustainable development, then I think if we can meet our present needs and without compromising the ability of future generations to meet their own needs, if we are selfish, we are going to suffer. And I think the bomb is ticking. Time is very, very limited. We are talking about artificial intelligence. We are talking about many things. But here is the point that we have to talk about, but sustainable development. It's over the years. I think so from the past 20 to 25 years, we are talking about sustainable. But initially, we couldn't even understand what is sustainable and how to make it a part of our own dictionaries. But now, I guess the time is very, very limited. And I'm sure today our dear students are here and they will be the torch bearers because they will listen to this, they will imbibe this, and we will move forward and with a positive frame of mind that we are not going to do anything to deprive our future generations. And hand in hand, science and technology are going to move so that our needs are fulfilled as well as the needs of the future will also be fulfilled. Today, as I saw the clipping that Dr. Abir Boron Mojumdar had sent regarding the Science Day celebration, I have seen that Dr. Varala is going to be one of the invited speakers, and we will be extremely happy to hear from a scientist. And he is a scientist from the Scripps Pharma, Hyderabad, and he will enlighten us and illuminate us regarding how and what about the key word sustainable. I hope we all will be a little bit more enlightened after we leave this online platform. Thank you once again to Abir, to Meeta, Pintu, Mukti, John Sir, and our numerous other teachers and students who have found a small endeavor from Kalipatho Ghosh, Tornai Mohabidya. Long, long ago, and we are bearing it, and we hope it is going to be fruitful for all of us. Thank you, and I declare the Science Day program in our college open. Thank you.
Thank you, madam.
Thank you. Thank you, ma'am, for your valuable words and appreciation. Okay, now, science is a systematic and logical study of how the universe works. The gift of science and technology is what we see around us. All phenomena are the product of science and technology, whether it is a smartphone, car, fabric, paper, radio, television, anything. Today, human being cannot imagine his life without many of these little or big things that are being created by science. request our Teachers Council Secretary, Professor Pintu Prasad Jaiswal, to share his views on this day. Sir, Pintu sir.
Yes, ma'am. Thank you very much. A very warm good evening to our respected principal, ma'am, Dr. Meenakshi Chakravarti, dear colleagues, and all my dear students. It is indeed a pleasure to have an opportunity to speak on this very auspicious occasion, that is National Science Day. Now, as we all are enlightened a bit by our principal, ma'am, that if we talk about the Science Day, so it has a direct impact on our daily livelihood. It's not only that the scientists are contributing from their end. I personally feel that the when the question of sustainable development arises, it is the contribution of we common people also that can actually matters a lot, because you see, I being a very person from a commerce background, I try to observe the things from the business perspective. Now, the term sustainable future. Now, in the business perspective, when we talk about sustainable future, it's not only about earning profit right now. It is about earning profit at the present as well as leaving something for our future generation also. The resources which is available right now is limited in nature. So it can't be that whatever resources are available, that should be availed to a very larger extent and nothing is left behind for our future generation. So here comes the terminology sustainable development. Or when we talk about the sustainable future, it becomes extremely important for all of us to think in a very practical approach, that how we actually can contribute. Now, obviously, today we'll be having our learned speaker, scientist, Dr. R. Varala, who will be enlightening us, obviously, in a very common way, in a very popular talk. He will be enlightening us regarding the entire. Obviously, we'll be hearing that also. But again, coming back to the business perspective, if we talk about the sustainable development or sustainable future, it has been widely adopted by various businesses also. So you see, there is something called ESG. In the business perspective, we are now seeing that the ESG framework is normally being used. Now, what exactly is this ESG? It is environmental, social, and governance framework. Now, one can see that if this environmental, social, and governance framework which has been developed and which actually is being
হ্যালো
which actually is
হ্যাঁ
being
ঠিক
given
আছে,
much
ওরা
more
পৌঁছে যাওয়ার কথা।
priority by
হ্যাঁ, তুমি
the
কমলকে
foreign
ফোন করে
portfolio
নেবো।
investors also, as
ও
there
আচ্ছা,
are
ঠিক আছে,
plenty of youth actually who actually are now investing in those companies who are following this model, this environmental, social, and governance model. So the companies, the investors are basically trying to invest in those sort of companies who actually are taking care of our environment also. Now, citing one practical example which we can see is, if you see the last 1 year Nifty's return. Now, we all are aware that the stock market, in case of stock market, there is one popular index called Nifty, which is listed, which is an index of National Stock Exchange. So there is this index, Nifty index. If you see the return, and then there is another index called as ESG Nifty index. Now you see, for this ESG, a separate index has been built, and the company which is basically incorporated in this sort of index are those who are complying with the ESG. So the return from this ESG Nifty index was much more higher than the Nifty index itself only. So this way we can see how the investors are also prioritizing their investment in those companies who are taking care of our nature. So all these actually throws lots of information to us also, that directly, indirectly, we are also a part of it, and from our end also we can actually contribute towards it. So it will be really great to hear Dr. R. Varala, his viewpoint regarding the sustainable future. And I wish that the program which is being organized by the Department of Chemistry, the initiative taken by our very own Dr. Abir Baran Majumdar sir, as well as Departmental of Environment Science, which is being lead by our very own Meeta ma'am. So I wish all the very best for this program, and expect that this program will throw lots of information to all of us, including our students. Thank you very much.
Thank you, Pintu sir, for sharing your views with us. Now, the time has arrived for which we all got together here. For that, I would request Dr. Abir Varun Mojumdar, Head of the Chemistry Department, to take the charge and chair the session. Abir sir.
Yeah, thank you, Meeta madam, and a very good evening to all. Uh, there was very kind words from Meenakshi madam, our honorable principal ma'am, and I think near about, if I can see, near about 60 participants are here. So it's a great session, and it's a big day. So uh, the theme, as it goes, that mm, the whatever we do in science should be sustainable. Science, in chemistry, still people are joining. Uh, Science, particularly in chemistry, uh, uh, is in these days is not only just doing research and publishing papers. A very very important aspect of organic chemistry, particularly which I and Dr. Ravi Varala Garu in Telugu means respected person. Let me tell you, since I was there for a few years, I know some of the terms, and uh, it's not about only doing experiments and publishing paper. Now a big thrust has been uh, to do experiments in such a way, to invent in such a way that would not harm our future. That means that would be sustainable. So whatever we do today, responsibility lies upon us, and every scientist, every in every lab, people are toiling themselves day in and day out to make the process sustainable. Whatever organic solvents in organic chemistry, since I'm the field from organic chemistry, so I can tell you that it's a big challenge, because most of the organic solvents are not green. Are not green means those are not environment friendly. So, and we started doing organic synthesis in organic solvents, but later on we found that that's not the way to do it, because the environment doesn't accept that, and that may lead to many harm in the long term. So green chemistry evolved gradually in the late 90s, and now it's in an, I, I would say that in a promising stage that involves every scientist in a cutting edge form, not only organic chemists, physicists, environmental chemists, all are together, fighting together to make the entire scientific research and invention sustainable. And we are only trying our level best to make out of it the most, that whatever we do today, that would help our next generation, that would make our world little bit more healthier, so that it can get back to its initial form, uh, uh, from where we started actually. The world has changed a lot. So I would not talk much today, because I have a person today, fortunately, because I had a very, very little time, and I rang Meeta madam, because Meeta madam is a direct person related to environment, and I have been from chemistry. So I rang Meeta madam, and we thought that okay, now let's do it within a day or day and a half. And fortunately, I rang Dr. Varala, who has been in contact with me, and has been an excellent scientist, research worker. And let me give you a very brief introduction of him. I have it in my hand. Let me read it. Dr. Ravi Varala did his PhD from CSIR, Indian Institute of Chemical Technology, Hyderabad, and from 2000 to 2006 he completed his PhD, and then went on for a postdoc research in Portugal during 2007 and 9, and then he started his research, and during 15 to 16 he was invited researchers and visiting scientists University of Sao Paulo, Brazil, He has now 90 published research articles in national and international journals, uh, attended and participated in more than 120 national and international conferences, and has published 2 books, 7 book chapters, and 8 review perspectives as on date. Got research collaboration with KSA Malaysia, and presently he is working as a scientist, as you know, in Scripps Pharma Hyderabad, which is a very, very, very well-known international company. And he is probably the fittest person today because he has been doing research in drugs, and he has been in pharma company, and he has been doing a lot of organic synthesis during his career, uh, and he has seen the changes. He has seen the changes, the way we experimented earlier, and the way we are looking for uh, to do more experiment that would be more, acceptable in green chemistry. So, Dr. Ravi Varala Garu, Swagatam. Uh, is it? Yeah. Uh, the stage is all yours, and we'll be.
Hi, good evening.
Yeah. Everybody please mute the students, dear students, everybody, uh, please mute your audio. And after this session there will be a short session for you. If you have any question, he is in a pharma company, so you may have some queries, so you can directly ask him. But for now, please mute your audio. Ravi garu, please.
So, good evening, one and all. Just a minute. Is it visible?
Yeah, I cannot.
Not yet, sir. Yes, sir. Now we can see, sir.
You can see the slides now, ma'am?
Yes, yes, sir. Yes, sir.
So, wonderful introduction by Dr. Abir, my good friend. And first of all, I would like to thank Professor Meenakshi Garu, then Bala, Abir, and the staff, and my dear students. So it's a privilege for me to just talk few words on the related topic, as we are well aware the essence, the theme of this particular 2022 is, as said by Bala Madam and Meenakshi Madam, integrated approach in science and technology for a sustainable future. As a chemist, actually, we we used to go in diversifying, like Abir said, in organic chemistry, we used to work a lot. Later on, we came to realize the solvents which we were using, like benzene, toluene, we used to basically dry it and use it for further reactions. And yeah, maybe after some years, it may be carcinogenic or what so. But green technology has come up, and we are also working on it apart from nanochemistry. So today's my topic will be dealt with two different dimensions, because as Abir said to me, not to go much into organic. Of course, we are organic, but because some students should be able to understand basics. Apart from that, I will be explaining you how our science can be really applicable into technology. So let's see. This is, yeah, of course, sorry. I should say welcome to the staff and students of Kalipada Ghosh Dharai Mahavidyalaya Bagdogda. I think I have spelled correctly.
Yes, sir. Yes, sir. Perfect.
So the first part, I have divided it in organic chemistry. The first one, which I will be discussing with you, it's playing with the thalidomide moiety and applications into synthesis of some biologically relevant drugs. So there are so many thalidomide, and very all of you might be aware thalidomide, of course, because in MSc everybody comes to know, even in M.Pharm, B.Pharm also. So let me talk about first the synthesis of indoprofen. This is
this non-steroidal anti-inflammatory drug. Everybody is well aware of it, and it, of course, it was withdrawn from the market, but presently it is being used for spinal muscular atrophies. So no drug will be wasted. Maybe if it is not suitable for this, it will be used for the other purpose. Like now we have seen during our corona, we didn't have time to realize a vaccine to find. So options, alternate options, remdesivir or favipiravir. So other drugs are being used. This is a hit and trial method. That's what we use in the industry. So I just like to briefly explain this synthetic steps. Very simple, except the last ones. Particularly will be useful for MSc students and BSc as well. I have taken orthotolic acid, and just it's a simple esterification. It can be done in the laboratory using concentrated sulfuric acid, ethanol. Then I have done the bromination using N-bromosuccinimide, because N-bromosuccinimide, because I'm just trying to tell you, it comes over the time, it turns into red. So we have to recrystallize, and the pure crystalline one gives you the highest purity, because industry wants the best yields, not just like in the laboratory what we do. So that benzyl bromide which we have got, and this is very important step in which we have come closer the chain. You can see the 5-member ring formation can be seen using 4-amino astaphylin. In the presence of base potassium carbonate, you get this one, and this one is a moiety in which next simple reduction which we have studied in BSc and MSc, like as I always say, reduction alcohol we have got, then we have got done the chlorination. This is very key step in where we are going to use the palladium catalyst, diphenyl chloride, and triethyl ammonium bromide, PTC, phase transfer catalyst also. And we have to use cautiously the carbon monoxide cylinder to incorporate the oxidative carbon monoxide insertion. Then just hydrolysis, then you get this endoprophene moiety. This is used. This is being used right now in the spinal muscular atrophies. So this is one, just in a shorter way I'm saying. And next, let us come to, most of us are well aware of this thalidomide, and we know the S isomer of this is teratogenetic, and the R enantiomer is useful, and it means it is used as a hypnotic drug alternative to barbiturates in the olden days. So what happened in the 1950s when Germans were using the first, when the medicine was discovered, the pregnant women who used to get pain when the baby is kicking in the inside the womb, they used to are born with abnormalities. Then they found out what is the reason for this, and thus as enantiomer is causing this teratogenicity. That's why this was also withdrawn from the market. So why I am telling you withdrawal of the market of indoprofen also, and this are also. But you see the beauty of this thalidomide, after 30 years, it means 3 decades after the closure by FDA, it has been proven as a wonderful anti-leprosy drug, and it is also being used as an anti-HIV drug. Even in the market also it will be available. So this is the S enantiomer and this is the R enantiomer. This is what I am saying. This one will be hypnotic drug, means it makes the pregnant woman has get comfortable sleep, whereas this has given the abnormalities which we are talking. And this is the stereogenic center. We can see the chiral center. Once you either inject intravenous or whatsoever S or R thalidomide inside the body, what happens is due to the racemation, due to our blood pH is between 7.4 to 7.8. So under these physiological conditions, it gets racemized, it gets epimerized, and anyhow you are going to get the racemic thalidomide. That is the reason this drug is called a classically quoted example of a drug developed as a racemate. So it's being used as a racemate, and for wonderful uses in the leprosy, because we have done the studies also. Let me go to the synthetic steps. technology perspective I'm talking about, because process research, if you see, this is the scheme 1 and this is the scheme 2. In the scheme 1, if you see, the starting material is N-carmethoxythalamide, and this is the simplest amino acid, L-glutamic acid. Just taking both of these and cooking in sodium carbonate, that gives you N-thallyl L-glutamic acid. It means you have two carboxylic acids either side. Just treat this with, I mean, you are doing the esterification, of course, so using methanol and thionyl chloride, you get the diester. And you can see, in presence of sodamide, because this reaction has to be maintained at minus 33 degrees Celsius in presence of iron catalyst, this diester, because of the conformation 6-member ring possibility, this cyclizes into 6-membered imide, and this is how you get the racemic thalidomide. How many steps? 1, 2, 3. In 3 steps. But the overall yield is 19%, you see. And this is not suitable in the industry. And next come to the other strategy in which we have done, take simple L-glutamic acid and do the esterification, then bark protection, deprotection are very, very important in the organic synthesis. And this diester, again, we have treated like in the scheme 1 using sodium liquid ammonia. And this cyclized bark protected one is there, then deprotected this one, and simply condensed with the phthalic anhydride, because there is no purpose to get an exclusive RRS enantiomer. Why I have said? Because once it gets into the body, it gets racemized due to epimer and the physiological pH 7.4. So there is no point of synthesizing S particularly. That is the reason we have synthesized racemic. And this you can see 5 steps, but the overall is 37%, and we have filed a patent for this, and even it has come in ACS publication in the other strategy. And this is what pertaining to the thalidomide. All of them are related to thalidomide. And the third drug I am talking about, this is very important one, baclofen. I think yeah, MPharm and MSc students will be aware of this name. Gamma amino beta parachlorophenyl butyric acid. It's a derivative of GABA, gamma amino butyric acid, because this works very, very important inhibitory neurotransmitter in CNS system of mammalians. So this is a racemic baclofen, R baclofen, and S baclofen. And in this earlier condition, we have seen racemic drug we have used for anti-leprosy and anti-HIV, etc. Whereas here, the company wants only R enantiomer, because the biological activity of baclofen lies in R enantiomer. So no company will allow it to get sold in S baclofen or racemic baclofen. So for that, we have done the synthesis as well. And if you can see, very simple steps. The phthalic anhydride, it's available everywhere in the laboratory, and this is the allylamine. Reading this, in presence of ethanol, you have to use the Dean star, because water has to be removed continuously. You got the N-allyl thalamide. This one, you have the olefin. So we have subjected it to ozonolysis. We have subjected it to ozonolysis in DCM methanol mixture, and you got the wonderful aldehyde compound, N-acetaldehyde, N-thalamide acetaldehyde. You can see this one. Then already we have prepared 2-carbon wettig. 2-carbon wettig is prepared aside, and this aldehyde is generated. And these two, upon combining, you are getting the alpha beta unsaturated ester. This is very, very important key intermediate for the synthesis of R baclofen. Now, 2 strategies we have used. One, synthesis in racemic baclofen. This is for the publication purpose, and the synthesis of chiral R baclofen for our industrial work. And you can see Isuzuki coupling, boronic acid is there, and here you can see this beta and phenyl group insertion has occurred, and different ligands we have tested. Among the ligands, second gave very good, and you can see using this ligand, when it is subjected to this, you get the R baclofen precursor, then you hydrolysis the ester, then you get the baclofen. And in this way, you are using just simple strategy, and you are doing nothing palladium you are using here, and you get the racemic baclofen. Palladium estate, bipyridine, you get racemic, and rhodium binap S, rhodium S binap. When we use, we get this one. So the overall yield of this synthesis is 13.4%. The racemic. This is the quite okay. Some more synthesis are there in the literature. They have better yields than us, but to our extent, we could satisfy this one. So these three, my present purpose is the science how we are converting into technology. Means you see the synthesis of baclofen, because ultimately what the industry needs is cost effective. If it is more costly, how can a patient buy it in with a lesser price? So catalyst, solvent, everything plays a major role, and the number of steps also play a major role. And the catalyst which you are taking it, and if it has recyclability, like Abir has said, enzymatic catalysis, you can use nanocatalysis. The more now industry is not like that, the conventional acids and bases, they are even using the silica and other things for various purpose, hydrotolucides, whatnot, hydroxyapatites in the industry, because reusability is very, very important. So we are also using, and these are related to some synthetic strategies. The first one is endoprofen, the second one is thalidomide, the third one is baclofen. If you see the difference between these three, why I have categorically chosen, this is a thalidomide derived drug. It doesn't contain thalidomide moiety, but we have used thalidomide as a protecting and deprotecting group. So that is, and in thalidomide, if you see, the thalidomide group is intact. Whereas in endoprofen, it has gone one carbonyl is reduced. So three different kinds of thalidomides I have shown you, and how to synthesize, and ultimately the medicine should be applicable at a cost effective manner in the industry. Once industry gets a cost effective way, the supply also will be in accordance. The next topic I will be moving to some other area which with the curiosity, because we got order from Hyderabad real estate, RERA, having got some experience when I was working in Europe. Uh, we put forth this idea to the builders, real estate, where how the chemistry can be useful for particle board preparations. So that's the reason today, with permission of Abir, I have taken this also, because very simple, but yeah, complicated in buying the things. I will show you in the next slides. So particle board manufacturing from agricultural residue with suitable binder resin. So this will be the second part B of my topic. So particle board is an agricultural residue based engineered wood. It is manufactured from wood chips, sawdust, agasse, coconut shell waste, cotton stalk, rice husk, and many other agricultural waste with suitable binder resin. So the purpose is, anyhow, in the next slide it is there. So later I will try to discuss what is the need for preparation using the bagasse or rice husk, which can be found in rice mills. So the target is to develop economical, sustainable, and eco-friendly particle boards with agricultural residue with suitable binder resin. The second point is reduced wood supply, increased the cost of particle boards, directly increasing the cost of construction. If you go to any construction, let it be apartment or individual house, you buy the teak, or you buy the other kinds of wood. The wood is being extinguished and extinct, and lot more necessity for plantation in terms of keeping the earth eco-friendly. So instead of cutting the trees, our idea, it means we have taken this idea from Denmark, but we are doing R&D in terms of resin and binders, how that we are changing the things to see the other parameters and working with mechanical engineers and the civil engineers to see the stress strain ratio, because the particle board, once it is prepared, you have to see the feasibility, because if somebody kid sits on the table and if it breaks, there is no use. So the dimension, the thickness and the durability, everything is important and we are working on it, and almost our trials are going very fine. Like rice husk. Once the rice we get the husk, which is and corn, whatever you can take, even coconut waste also. That avoids crop residue burning, making it beneficial to users and environment as well. So, what is the manufacturing process? Outline I will be telling, because in our industry we have taken 3 acres in Karkavatla near Hyderabad, where this R&D is being done. Uh, Raw material of drying in dryers, grinding, crushing means you take the rice husk, and you have the different particle sizes. You have to grind it, crush it, and then you have to make it to bring to suitable particle size, so that a perfect thickness containing particle board will be coming. And then how they will be mixed with resin, wax, forming agent. These are very important here. This is where our R&D works, and making form mat in suitable dye, and of course hard pressing, edge cutting, all these things will be there. Where do we use this particle board furniture? Of course, instead of alternative to the real wood. Why I am telling you? Because the sustainability is important. The woods are being cut, the trees are being cut, and for growing of trees from plant stage, it takes several years. And as we are in the technological arena, so much carbon monoxide and other poisonous gases will be evolving. So it's better taking alternative option like we are preparing now: furniture, flooring, cabinet making, soundproofing, building partition, false ceiling, insulation, and so on. Like I have shown you, and now people can see where the same wood, instead of wood, what we are doing, the synthesis from the rice husk, waste of sugar cane, waste of coconut, that upper one. So, and we are taking those things and we are making this particle board applications, like even the computer table, you can see office table, and false roofing. So there are so many steps in this to make the particle boards. Size reduction, as I have said to you, because it comes in different sizes. Because you don't, in the initial stage you do the 100-gram scale, but when it comes, you have to do in the kilo scale, quintal scale. So the size is very important, because you have to get a uniform thickness, and you should not have gaps, because air, chemical, flame resistance should be there, isn't it? Because those are the particle what defibration. Because basically, what this bagasse or coconut, let's take rice husk, corn husk, what they contain? They contain lignocellulose, means carbohydrates only basically. So we have to delete that defibration. We have to do with the pressure. Then resin adhesives we use, blend. We will blend with some other mixing chemicals to give them more rigidity, and mat farming, other things, hard pressing. I will be showing this. So mostly, as of now, even in Denmark also, the particle board, they are using it more regularly, because they love the plantation and they don't want to cut the trees. So they exclusively depend on this particle board preparation. In India, some companies are doing, but not full-fledgedly. So most of the resins are urea formaldehyde based. As of now, we have changed this and we are using other ones which say, company matters and natural gelling agents like starch, tapioca. These are the resins. So what a particle board should have, of course, the table, whichever you use, the table, the chair, if it is a wooden chair, it should be resistant from fire, water, termites, insecticides, or worms, decay resistance. Because you should, these are very important qualities. One should prepare particle board if and what are the physical properties? General average and target density should be 800 kg per meter cube and flexural strength. This is elastic. This is elastic modulus. This is where stress and strain comes in. And what are the chemicals? Generally, we use sulfuric acid, urea formaldehyde, and other resins, rice husk. We get from the local. We talk to the district rice association, and they supply to us in tons load, and we pay them according to the needs and some simple chemicals. But the strategy is very important. How we are going to do, and this, if you imagine any sheet, if you have a laptop, I mean computer table before you, also you can see the the shape in which the core layer is middle one, the upper, the top and the bottom one, you call it as a face layer. So this core layer is very important, where we will be adding forming agent. Means it has to fix very nicely, and wax and other things will be added on the top and this. So this one we will take. I'll show you the slides. This is the hydraulic hot press in which we do the reaction. We have the pressure and temperature parameters set depending, because we do the R&D now, so it's at 250 degrees, 300, 150 degrees, and top pressing and bottom pressing. We make the molds and we think 4 mm thickness, 6 mm thickness according to the needs of company. We prepare and then add adhesives and other things. And for this setup is very important. And this is a saw machine for cutting the wood, and this is mat forming. This how whatever the sheet we get now, so that converts into uniform mat. And this is the dryer machine. You have to dry the things, and in which mixing occurs boiler, and this is a mixture the same. And this is a Japanese instead of statistical like ISA we have now. For wood, to check the quality of any wood, JISA standards have to be followed, in which thickness swelling, water absorption, modulus of rupture, modulus of elasticity, internal bond. All these parameters have to be done on 5 6 batches, not just single batch and you give this report. No, no, it has to have the repeatability and the same strength. It should be processing. So this is how boards we generally synthesize like this plants. We synthesize, and the middle ones will be core and the upper ones will be face area. So thank you, Dr. Abir, Balagaru, and other staff uh, from your college. It's my pleasure to interact with you. And yeah, any doubts, I am at you. This is two different fields I have been discussing, like organic, and the other thing is which comes into regular usage. Like because as an organic chemist, I cannot be limited to that field only. I have to expand my subject. So I have to obviously it should benefit commercially also. So that is the reason we have been doing separately on the name of Swastha Organics. We are synthesizing this aside with the permission. Thank you, one and all.
Thank you, Dr. Varala.
Yeah, are you able to hear?
Thank you for the splendid presentation. And I understand that it's very difficult for a hardcore organic chemist like you to address all of us, because we have from multidisciplinary background, and also we have students from,
Exactly.
yeah, from arts, from commerce and science. So even from the science background, the students are from science background. Uh, some of the drugs synthesis, they're part of their syllabus, so they must be enjoying it. And the second session was related to the particle board. I think everybody could enjoy it during that stuff, the technology involved in it, and the way it has been done, and that the way it's been synthesized in your lab. So I would once again thank you, and I would like to request the students and the audience or respected teachers, if you have got any queries, please.
Please, please, you're free to ask me.
Hello, good evening, Dr. Varla.
Yeah, please, Suman.
Thank you very much. I'm very much enjoying your presentation and different syntheses and catalysts you have mentioned here. And I am basically the background of the economics and the faculty of this college, Alipodo
Yeah, yeah.
College.
Please.
So, actually, the topic has been started here, the sustainable development.
Yes.
On behalf of this topic and the subject, I have a little queries about that because I have a lot of friends in chemistry background and they are talking about the cost benefit approach of the all industries. Actually, all the industries are giving their more effort to how to generate more cost benefit research.
Sorry, sorry. Can you be a bit louder?
Hello.
Yeah, yeah, please.
Yes, actually, a lot of friends I have.
Yeah,
I have
yeah.
a lot of friends, those who are working in different industries, and they're talking about that the industry are basically giving their more effort in to perform the more cost benefit research. Actually, they are trying to finding the molecule, how to generate the more to innovate the new drug, new molecule or new drug, whatever in your background. Actually, their basically objective to how to find out the more cost benefits from the in their supply the different drugs, which will substitute to the another drug. Just like I have heard that Alzheimer, one type of the disease, and that disease has the different medicines have in our market. But few industries, few here also, a lot of here we have, they're trying to find out. My objective is, my question is actually this cost benefit approach, how it's friendly, how it's friendly to generate the sustainable development in real world, where the cost benefit processes comes and the market profit comes in. And whenever the market is comes, it's profit motive to the cost minimization. Then how to protect our resource actually. So this my question is specific this cost benefit approach, how it's viable for maintaining the sustainable development. This is my question.
Yeah. Thank you, Suman. So the thing is that I would like to give an example because it's very vast. To get the cost effective market approach, of course, from industry to consumer, even I'm talking about. So, like every important CRO should be having R&D facility. They should not be focusing only for commercial gains like synthesizing XYZ and throwing on to the market. Advice, if you see very important like the Dr. Reddy's or if you see Lupin, they will be having R&D centers in which the cost effective approaches are being worked out. Already suppose if you have some literature data for X to Y conversion, that how you can minimize the reagent catalyst, solvent, and even temperature conditions, because that has to all these together will definitely result into cost effective way if we do proper R&D. That is what I am saying. Just in a CRO, taking the literature and doing the things, and you get the drug, that doesn't work out. In order to reach common man at cheaper price, there are so many things, like as Abir was also mentioning, even other alternative green technologies like enzymatic and nanotechnology are much being used right now in industry also. It was in 2020 or 2000 before, I mean 21st century. This now even in Aldrich company, if you have heard our companies where they majorly Merck, etc., they are buying our synthesized catalyst, nano catalyst, and they are giving us 20 years grant and other royalty also, and they are using in their own companies, because my friends work in US in Merck and other pharma companies, where these cost effective heterogeneous catalysts are being used. So, for example, I didn't mean to tell you, hydroxylation is there. Dihydroxylation is osmium tetroxide we use. Okay, and that is anchored with silica now and with other reagents, and we can reuse it several times. And earlier days, the wastage osmium tetroxide is being thrown out. So, a lot of improvement has come in industry, in esteemed industries. I mean to say, obviously, the cost effective will result in cheaper price to the final reach is consumer, the customer. Sumanji.
Yes, thank you very much. I really enriched your valuable information. Thank you so much. I'm really satisfied. Thank you.
Thank you.
Anybody else from our respected teachers or the students?
Particle boards, when you go home, you please check the shape in between. If it is not laminated or if it is not colored, you can see the layers. You can see the layers. Then you will see. I request Dr. Abhi to share this to the students, so
Yeah,
that
sure.
they will be having technological advancement. How chemistry can be used for particle board. Of course, everything is chemistry. Let it be plant or animal or whatever the thing. But I mean to say, how we are bringing it into real use. So you can check, if it is not coated, you can see the in between core and face layers. Strictly speaking, I want to tell you one more thing. Compared to the real world, this will be having less strength. We accept this. But the ultimate purpose to make the cabins in software companies, we don't require the real big wood quality ones. These are enough. Just we get laminate and we use some years very cheaper price compared to that. If that 4 mm thickness is 20 rupees, we give it for 5 rupees. So you see 1/4 reduction is there. So that's a sustainability, obviously. Yeah, strength relatively lesser.
Okay, uh, Dr. Ravi Varalagaru, I have actually mm, two questions. One question is related to research, and another question is related to the prospect of our college. Since you are directly from industry, and there is a big prospect in collaboration with the industries, I'd be looking for it. But first of all, let me address the first question. You have worked in Europe and outside, and also in South America, and also you are working in India. Uh, what I found during this industry collaboration is that the research they appreciate is little bit different from the research we often get interested into. Like if you get a new finding in your toiling research, that may not be as much interesting to them. uh, like they want a targeted focused approach, which also we may not like, right? So how would you differentiate things? I mean, how the research in Europe or in South America or outside India, you feel different from the research we are doing in India?
So, can I?
Yeah, please.
Rightly said, MCROs, API or impurity profile, wherever you go, let it be Europe or US or India, unfortunate thing, yeah, we face as industry people is do what we order, get it done, what given to you through your MSCs. Okay, so less R&D is being focused, less R&D is being focused, and we have to be limited for the companies what they require, and we are supposed to deliver it. This is the thing. Even in Europe also, this is the same strategy.
Okay.
Because yeah, if you go to the academic research laboratories, I tell you, Abir, IITs stand a bit to the graduate level of abroad universities. But if you seriously talk about NCL Pune or even CSR, ISET, also, there is no basic science. Like when we were learned, we did chemistry, but we don't know much basics. After when we went abroad only, we learned the real science, the mechanism. Every week we used to have seminars, sessions. That made us later. Early, when we were in India, we just used to have X to Y conversion.
Okay.
A published sale. But there, the real chemistry exists in academic research in abroad. Coming to industry, it's common everywhere because you don't get that any stigma
Yeah.
to try different things. Because you have less time. You are supposed to give it in due course, and you force your under people, and our boss forces us. So you don't have that much scope in CROs.
Right.
Either side. Let it be.
Yeah, I mean,
Brazil.
don't you feel that the science is compromised in that aspect? I mean, whenever you put pressure on a scientist, the brilliant thing which we could do without that pressure cannot be done. I mean, under pressure. So, don't you feel that the
Can be
science to an extent is compromised?
can be done. Where the thing is that like Suman sir is also economist. If suppose X doesn't come to me, he will go to the other company. So
Yeah.
there is a market demand. If suppose you, your company is dragging, if I am not accepting that one, immediately they shift it to some other GSK or GVK. So I am losing my business. In the motive of commercial and aspects only, compromisation is being occurred. Only R&D for name's sake, many industries have kept because they have to have the corporate social responsibility and other things. But like rightly said, it's a very unfortunate thing. Science is being compromised. Science is being compromised.
Yeah, thanks so much. And my next question is actually from my students. Actually, I am asking for them on behalf of them.
Okay.
Uh, that science is being taught in our college, and you are in a pharma company, and you have been in touch with the pharmaceutical industry. So, what you can suggest so that the students can get a job, or in the pharma company? What are the key
MSCs, you're
requirements?
talking about
Yeah, no, they are.
MSCs. No?
Yeah, pardon.
Are they MSc?
No,
I
no,
mean,
they no, no,
postgraduate?
they are doing graduation, they are doing graduation, and
Okay.
as you know that the colleges are now under choice based credit system, so the syllabus is modernized, and there it involves many things like including green chemistry or nanochemistry little bit. These things are there, as well as some practicals are there related to drugs design and synthesis. So right from here, with this background, can you suggest that what can be done so that the students may have a bigger opportunity in the pharma field?
Uh, because to my personal experience, when I was about to finish my PhD, I'm talking about for graduate also.
Yeah.
The thing is that yeah, we should have basic science. Means subject knowledge we should be having, not just a number of papers because when we were in IICT also, I tell you, strictly speaking, we were in fancy of getting papers. We didn't at that time because it was like a competition field. But when I was taught with the Nobel laureate in abroad first DHR Barton student, she has taught me the real chemistry. So I always suggest young budding students not learn like us because we have wasted so many years. In abroad, I have seen the BSc student is having more knowledge than the person who has done so many. I have done bug protection and they are using there. But when I went there for the first time, they said, we are using your JOC bug protection, we are using this. And I was the first person to synthesize dihydropiridine at room temperature. Before it was 100 at reflex temperature. So I always suggest the young budding students, please have basic grip on the subject. If you have subject knowledge now, nobody in the world can kill you either with politics or if you have thorough subject, you can get into industry, you can get into education field, you can get into other jobs. But unless if you are not having potential subject, peripheral knowledge, with peripheral knowledge you can get job peripherally, but to work there your metal should be proven. So subject is very important. So learn the basics. You cannot just say, for example, even many people I tell you, even coming to the period table also, know what is the metal, what is non-metal, which is located there. Even in MSc, certain people are missing where is deep black or yes, metals, metallites, how many metals are there and what is the difference between. So the basics, the fundamentals always help us because in interviews also, when I was interviewed in Wakad, Aurangabad, when I was in the first my jobs, I was selected there and during the same times I used to go to calls. I went to GSK Mumbai. I was not selected in the third round because they will be having rounds of interviews in which they show your posture, your confidence level. If you do not know, just say simply, sorry, I forgot. If you really know and you don't remember at the time, you can say, I forgot. If you really don't know, I don't know, sir. Sorry. But if you have subject, sometimes luck also should favor. To get into the jobs, I'm talking because Abir has asked how to get into the pharma companies. Good pharma companies means if you have commendable subject and the zeal to work, then I think one can fit in.
Okay, thank you so much, Dr. Varala. uh, mm, one question, one last question probably I would ask, and that is related to both academics and research. And you have been also in
Yes.
academics, I know that. And the CBCS, the courses been everywhere in India, and you know that the infrastructure uh, we have in colleges, like in any college in Delhi or in Hyderabad, is different from the colleges we have in other places. Like in our college, we have a very limited sort of infrastructure. Now, do you think that this new system, which you know mm, uh, is intending to have both academics and research activity inside college, Also, encouraging students to be involving in research uh, is applicable to Indian colleges like us, or I mean, it has been imported from America, USA. I know that, but the entire system, whenever we import something, uh, the problem is uh, we don't get that much study or the information from the colleges, all the colleges we have. We only concentrate upon some cream colleges and some cream places. So, what do you think that how can it be more effective? The CBCS. I am talking about all the science subjects because it's not a matter of it's not a problem of chemistry only. It's a problem of physics, even environmental sciences, and geography, geographical sciences. Yeah. So, what did you say about it?
No, it's my view only because the only thing is that provided adequate funding and facilities in the colleges, then only this works well. If it is not there now, then in Indian system it doesn't suit well, as I feel. As I feel, because it's my personal uh, conception. Seeing the scenario, what equipments, what circumstances we are having in our colleges, universities, I don't think this we get benefited. This is what I feel personally.
Okay, thank you so much, Dr. Ravi Barala Garu. And now I would like to shift this to Meeta Madam once again. And we are honored actually having you, and we'll be looking forward to have you in future days. Thank you.
Sure, sure, sure. Please, whenever you happen to come to Hyderabad, please visit me and take care of your health, Abhi. First, that is
Oh,
there
you
because
remember
it's
that?
been
Yeah,
long time. I talked
yeah,
to you. It's been
yeah,
long time. You just day before yesterday, you messaged me.
yeah,
I,
yeah,
if
yeah.
I'm right,
Yeah, I was fortunate that you have seen it.
Okay.
Thank you.
any issues, please talk to Dr. Fani Krishna.
Yeah, sure, sure. Thanks so much.
Okay. Thank you, Dr. Varela, for enlightening us with use of science and technology for making more affordable and effective medicines, as well as use of discarded agricultural residue for the manufacture of particle board, which is certainly assures a sustainable use of resources. We have really enjoyed a very interesting and enriching session. Now I would request Dr. John Breckness-Tirki, coordinator of IQAC, to present vote of thanks. John, sir.
Okay. Hello.
Good evening, sir.
Good evening. Good evening. It's your respected principal, madam, the organizers, Dr. Abhirvan Mujumdar, sir, Meeta Vala, madam, our TCS, Sri Pintu Prasad Jaiswalji, my colleagues and students. We had a wonderful evening today with Dr. R. Bharala, listening to him on a very needed area, the science and technology for sustainable future, which is really a very important area to know and to save the humanity in future. So on behalf of the Kalipada Ghosh Prime Mahavidyalaya, I express my sincere thanks to Dr. R. Varala for accepting and presenting a much needed area of area of the subject that we must all know, and of course we need for the betterment and welfare of the humanity. I hope I am not from the science background, so the student must have really enjoyed listening to you, because we know the sustainable future is at stake if we do not take a cautious approach for really making the future better. So, Varala sir, really we had a wonderful time, little more than an hour. And so,
to be with you.
yeah. So, thank you very much, and all the participants here on the Google Meet, and we are looking forward to have more such program. So thank you, the organizers and Dr. R. Farala sir. Thank you.
Thank you, sir. With this, we come to the end of this webinar. Thank you, everyone, for being with us and make this event a complete one. Thank you.
Thank you, Dr. Ravi.
Thank you.
It was wonderful having you and sparing your time for us, a remote college somewhere in the district of Darjeeling. We would love to have you with us once. If you can make the time, it's a wonderful place. Okay?
Hope a day will come. And
Yes.
actually, when Abir asked me, strictly speaking, madam, what should I speak? Because organic chemistry related means I can go to my level extent, but
I can understand.
when Abir said, no, you should not go much, it doesn't mean that it should not miss the flavor also. So I was thinking, okay, I am doing in different dimensions, like interdisciplinary. I have gone into material science by making particle boards. So that is a common thing. Everybody will be able to understand. That is the reason. Thank you, madam.
To some extent, yes, your particle board. Because nowadays we see so many doors being made, the furniture being made, and even tabletops, as you mentioned. And that was relevant. That was very relevant. And once again, we invite you to the district of Darjeeling. We are in the foothills, okay?
Thank you, ma'am. Yes,
And it's very different from Hyderabad, okay?
sure.
But it is nice. Thank you for a pleasant evening.
Thank you, John sir, Bala madam, Meenakshi madam. Bye, Abir. Take care.
Thank you, Dr. Varala. Thank you, everybody. Thank you so much. Thank you, everybody.
Take care.
Okay. Thank you. Thank you, everyone. Okay. Sir, leave kodi dale.